Hey guys.
Hello.
Hey. We're just having a little chat, casual conversation about Angelo and I. My name's Jason.
Angelo. How many of you guys, do you guys know anything about Bitcoin or cryptocurrency? Like, what would you gauge your knowledge, like, between 0 and 10? Like,
I started research today.
okay, so you're the low end. No,
Like
4s, 7s, 9s?
Probably.
I imagine we could assume that most people don't.
Alright, no, I was just curious. It's good
Yeah.
enough. Maybe there's that one person who knows.
Yeah. Cool.
Alright, you.
Keep yourself knowledgeable. Hello.
Did you buy cryptocurrency a while ago, or is it just
I
like...
started in 2008 when Bitcoin was like a couple cents.
Mhm.
So I was like, why not? I'll put $50 into it.
Nice.
And then I held on until it was around 1600.
Mm.
And then from that point on, like it fluctuated from 400 to 1,000. So I would either buy it low or then wait until it get high and then short when it went down.
Mm. So you like to play that as a trading game then?
Yeah.
Alright. Yeah. Not for me at least. I just been hold. I'm a HOLD hold.
So I suppose we could just get started.
I suppose, yeah.
We good, man?
Yeah.
Cool.
A lot of people are allergic to sitting in the front now.
It's
I wanted
okay,
to sit
guys.
next to them, and then John decided to sit over there. So there's
We should make the text really small so they have to come up.
Yeah.
See?
I was making it bigger a second ago.
Yeah, you were encouraging them to stay back there.
Apple Z here.
All right, yeah, so I'm Jason Robert, and that's Angello Pozo, and we are co-founders of HelloSugoi, which is an event ticketing platform built on the Ethereum blockchain. And we're going to talk today about the evolution of blockchain, and starting with Bitcoin, and then kind of focusing on the implications of the technology beyond Bitcoin. Yeah, so let me get started here. So this is going to be our agenda for today. We'll just kind of talk about blockchain and Ethereum on a high level, and then dive a little bit deeper into some use cases for the technology, maybe give some examples of some companies who are tackling those issues, and maybe even have an open discussion about some possible implications for the future. Cool. So, what is blockchain? Show of hands. Does anyone know what this whole blockchain thing is?
No.
Kind of?
Kind of, sort of?
Just a buzzword. Bitcoin. How about Bitcoin?
Yeah, we got
Bitcoin.
that.
Alright. More people know Bitcoin.
Okay, so we're going to do a quick demonstration to describe what blockchain is. Blockchain is essentially a database that records transactions between people, and it records them in a transparent, open ledger in an immutable way which cannot be changed. And it does so in a distributed fashion, which is really interesting. So let's say, for example, I have this ticket here, okay? And I want to send this ticket to Angelo. Here you go. All right. So this transaction right here has been broadcasted to a network of nodes. And each node validates the authenticity of that transaction. And it does so by running this computer algorithm that solves a puzzle. And by solving the puzzle, you get awarded more tokens and also verify the authenticity of the transaction. So basically what it's doing is it's saying, does Jason have the funds that he says he has? Does Angelo have the information attached to himself that he says that he does? Are the addresses legit? We can send or create that transaction that gets broadcasted to the nodes. Once it's verified, then the transaction gets logged onto a block or a ledger that says, now Angelo has this ticket and I no longer have the ticket, okay? So that gets recorded onto a block that then is chained to the blockchain, hence the word blockchain, in such a way that everyone in the network can observe that transaction, so it's transparent. The consensus that validated the transaction was distributed or decentralized. And it is immutable. So it gets locked into the blockchain in such a way using advanced encryption so that it cannot be changed. So that's much different than the kind of client-server relationship that we have on the internet now today, where the databases are opaque, the information can be changed, and there are a lot of intermediaries and third parties getting in the way. of the transaction. So in this case, it's peer-to-peer. Angelo and I are trading directly. Everything gets validated in a communal.
And we both have access to see what the current state of the system is. That's kind of the purpose. Like we're centralized. Like Facebook has everything, and Google has everything. You can't go in and like actually check.
Right.
You go to the bank, you can see like I sent this money, but you know it's like still pending and stuff like that. Like you don't actually see the lower level work. They're kind of abstracting that for you. And here it's really just us, and we are using a system that uses this blockchain to kind of make sure that everything's true. So like he has access to this ticket, and it checks like, can he send this ticket, right? That's what he was trying to talk about before. It does the sort of things where it's a distributed verification, and we all can trust the fact that if it got into the block, it's actually the true state.
Right. It's essentially digital trust, right? And we'll talk more about those implications moving forward. Any questions,
Yeah.
guys?
So just to clarify, here you're seeing all the background processes that are taking place that you don't usually see when you transfer. Okay, and then everyone else can see it too, not just
Everyone can see that I'm trying to send some coin
Okay.
to you, and the system verifies that I actually have those funds.
Okay.
So it does a couple of things, like it checks that if I say I have 10, the system will go, okay, do you have 10? Give me some hashes of that you have 10. And if I can provide them and they're inside the blockchain, then it'll accept them as valid. If I try to fake it, like say I have actually 12, the system's gonna go like, wait a second, I found out that you only have 10. You can't send 12, and it'll reject your thing. Your
Okay.
transaction.
And the addresses, so your address is public to everyone else too, or just between you two, since you guys are
It's a public address. So think of an address as kind of like a bank account number.
Right.
So if you want to transfer or send funds to somebody using traditional banks, you would use
Okay.
the bank account number.
You also have a private key that you get to kind of keep yourself and be secret from everyone.
Yeah, that's like your password to your online
Yeah, it's your
banking.
password. You don't actually share it. So you use your password and your public key to kind of sign something else that gets verified. Like the only way that this proposal is if you actually have the private key. If you don't, then I'm going to reject it because I can easily detect that change.
So the transactions are operated on by these miners and added to possible blocks, right?
Correct.
Is the inverse the same for the lookups? Is that distributed over miners? Or is that like a more, since the blockchain is public knowledge, I scan the whole blockchain myself?
You can scan the whole blockchain
Yep.
yourself.
There's a website, was it Etherscan?
Yeah, there's
where
either
you can
scanner
go?
for Ethereum, but there's also some similar ones for the blockchain. So you can actually like, if you find a wallet, like a donation wallet, you can grab that hash, go to one of those websites, put it in, and see like every single transaction that got put into it, for example. And you know that this person, or this address at least has, $1,000, whatever it is.
Cool. Let's move on.
Cool. So that's the underlying blockchain.
All right, so to understand Ethereum, let's talk about Bitcoin for a minute. So Bitcoin is a blockchain, and Bitcoin essentially utilizes the underlying blockchain technology. And Bitcoin's value proposition is the exchange of digital money, right? So we could transfer goods and services or transfer Bitcoin over the internet to purchase goods and services. So Bitcoin is all about money. Ethereum, on the other hand, is about programmable money. So it has an application layer that enables entrepreneurs and developers to create interesting use cases and applications on top of that underlying technology. So for example, we're doing event ticketing. So basically a smart contract, which is one of the interesting aspects of the Ethereum blockchain, enables us to write in rules or logic, business logic, that can be executed on the blockchain.
Yeah. So in Bitcoin, you kind of just say, hey, I'm going to give 5 Bitcoin to this other person. Right? There's really just like a plus minus going on there. It's a little more complex than that, but just think of it like that. In Ethereum, you can actually start writing logic. You can now go like, I can only send it to you if it's after Sunday. I could only send it to you if some other set of conditions from other parts of the blockchain are met that I don't have control over. Like let's say I can only, we're all trying to kick fund. If I make a Kickstarter, I can only withdraw the funds if I reach $1,000, right? So I have a function that says withdraw. It won't work because the check is going to be, does it have 1,000? No? Okay, return error. If it has 1,000, it gives me the actual result. So everyone else has to kind of donate. So that logic can be put on the blockchain rather than having to be a Kickstarter, which is, aggregating all the lists of credit cards, how much they actually sent.
Right.
And with this sort of system, I can even see how close I am with the actual state of the system is. I can see like, oh, there's only 800 left.
Right.
You could still do it on Kickstarter, but what happens if the credit card gets changed? If someone lost their credit card and now this person has to do something, and so Kickstarter makes that easy by fronting the money and stuff like that. But there also that ginormous 8% fee or whatever.
A real simple example would be just showing up at the door to an event with a ticket, and this ticket is associated with myself, and if I hand it to him and he scans that ticket through a QR code, it invalidates that ticket. So that's like, if I am the owner of that ticket and I am arriving at the door to the event, the ticket gets scanned, it becomes invalid.
And the block, basically the scanner would go like, invalid, I received this ticket from Jason, I will invalidate it, and the next time someone tries to scan it, I'll go to the blockchain and go like, hey, wait a second, this is invalid now.
Right, and that gets logged onto that database where everyone can see that and verify that indeed the ticket is no longer valid once I'm inside the event.
So the nice bit is that it can replace sort of the server database relationship that you kind of already know, because you can do that now, except now you can do it in a different way with you get all these extra benefits.
Right. Reduces double spending. That was a big problem that Satoshi Nakamoto, who's the entity who released the Bitcoin white paper in 2008, solved that problem. Because as of now, you can replicate a PDF or an MP3, which has been a huge pain point in the music industry, ad infinitum, and double spend as much as you'd like. So for example, if you were to purchase a ticket on a secondary ticketing market site like StubHub, or through somebody on Craigslist, well, that person could have 5 different copies of that ticket on the internet, and to first come, first serve, you can sell 1 copy of it and then double sell it again. And it's kind of up to whoever shows up at the door first to get into the show. There's no way to verify that there's only 1 digital unique copy of that ticket, for example. So the kind of distributed, decentralized nature of the blockchain enables those kinds of things to happen in a frictionless peer-to-peer manner, which is really interesting.
Is the kind of the stronger loose guarantee here based on velocity of the miners, or based on majority vote? So like, if say I try to double sell, what's the mechanism specifically that stops that from happening is it that transactions move too fast because there's so many miners, or is it that I broadcast it and it's processed by kind of the majority vote?
So once in the picture before, like all of these are unprocessed. These are all like transactions that you have. Like you said, T1 and T6, or you're trying to spend the exact same coin, or you're trying to do that same action. If on the next block one of them gets in, let's say 6 get in, this one is going to be rejected because the system will check like, do you actually have 10 Bitcoin? Be like, wait a second, no, there's this other transaction that happened. This is now invalid. Now, what if both of them try to get into it? The system's going to reject at least one of them and go like, hey, these things don't work. What the fuck? And it'll just, I don't know the rule for that, but I think it just picks one.
Right. So there's a strong guarantee that you won't be able to double spend, but not a strong guarantee on who will get the result necessarily.
Yeah, and that'll depend on how long it takes to get into the system. So like on Bitcoin, it's about 10 minutes. On Ethereum, it is like 12 seconds, 10 to 15, depending on the current mining hash rate. Cool.
All right, let's go to the next slide.
Well, yeah, that was Ethereum. Any questions, like possibilities? Can anyone think of an application that might work on an Ethereum thing like that? Now that we've described that a little bit, no?
So could you do something like, so I know like a big thing is like escrow, right? So
Yeah.
some amount of money gets put into essentially a third-party wallet,
Right.
with the idea that it will be distributed based on some criteria, right?
Right.
So is this a good?
That's a fantastic use case for it. Yeah.
That works, yeah. And both sides can see that it's actually there, right? If I'm trying to buy something from them and I have to put an escrow, I can say like, I did put it, and Jason can look at the exact same blockchain and go like, oh yeah, I did. There is $1,000 in this account somewhere.
And when the conditions are met, then that unlocks those fundings.
Yeah.
And if the conditions aren't met, then there's no way to fund them.
Now, some that you actually bring in an interesting position where there's on-chain and off-chain verifications, right? There still has to be some sort of way to kind of inform the blockchain, because the blockchain can only know what's inside of it. So there are sort of services outside to kind of they're called oracles, that can provide that third-party authentication. And their purpose is to be truthful sources of data.
Right.
Right? So if we have a bet that Mike Tyson versus Muhammad Ali is going to happen, the Oracle is going to say who actually is the winner. And the reason they might not want to be a liar is because if their reputation goes down in terms of like, oh, this Oracle is unreliable, we can decide when we make our bet not to use that Oracle. We'll pay someone else to do that, someone who's more trustworthy. So that aligns people's incentives to actually be good parties into the system. So because if they lie, then they might win that one thing, but now they're losing on the potential.
And that reputation could be logged onto the blockchain.
That can be logged on blockchain.
So you can go
like,
back in time to
you
see.
you can actually see that they actually lied if someone actually
Yeah.
did some extra other things.
Let's talk about some use cases. All right. So this one is particularly pertinent to myself as a songwriter and producer. For those of you that came in just a little bit ago, we kind of got started together trying to use blockchain to solve some of the issues facing artists and musicians in the music industry. Let's use one example here, royalty payments for streaming or for a synchronization. So I work at BMG Production Music, and if I get a synchronization in a big TV show, like I did the Mindy project on Fox recently, it may take me a year to get paid, and the kind of intermediaries and how much they're taking out of the cut, I don't get to see that. And the accounting can get very tricky, and it takes a long time for those payments to be processed. Upwards of a year, actually. If there were a blockchain solution to that, and as a matter of fact, there are a few, like
there's a couple
Ujo
projects,
Music
Ujo.
and Jack, for example, that have embedded inside the music or inside the file the splits of how much someone gets paid. All of those transactions can be broadcasted in the open, transparent ledger. So I myself, as a musician, can check to see where the funds are being held, how much I'm getting paid, and I can point to my address and get paid instantly. So every time that episode of the Mindy Project airs, that my music is in, I get paid instantly. And the accounting is transparent and open and logged on to the Ethereum blockchain. So it makes it a lot easier. There's less friction. It cuts out some of the intermediaries that hold up the funds. And it's borderless too. So
Yeah,
the
doesn't
blockchain
matter
doesn't care
where.
where you're located. You can get paid instantly for really any amount anywhere in the world.
You can probably explain like the Spotify case.
Yeah, so
More
we have some examples here. As things exist now, you can see from the multiple bubbles on this top row, there's a lot of intermediaries that are taking a cut out of the money that I am owed. Now, they do provide a necessary service, but I believe that this could be mitigated or resolved much more so with blockchain applications.
Yeah, so for example, like you listen to something on Spotify, right? You pay your $9 or your $10, right? You're just kind of listening, you're hunky-dory. But in the back end, there's like deals that are like with the PROs or something like that.
Those are performance rights organizers and their organizations, and they're the ones that keep track of when and where the music is played. So if it gets played in a restaurant or on radio or on a streaming service like Spotify, they're the ones that communicate back to the label who is distributing that music, how many times my song was streamed.
So Spotify would just like send an Excel sheet to a company like that. The company would go like, okay, what kind of contracts do I have? And like shift everything, make another Excel sheet, go like, well, these people are tier 1 and I pay them this much. These are tier 2 and they pay them this much. Based off whatever contracts they've negotiated, right? It's literally just those two people. And then they go out to the label and they give those, hundreds and thousands of labels their PDFs. And then the label goes like, okay, well, I got this much, and they do more shifting, right? I don't know, God knows what, based off the contracts between the artist and the label. And they do that for every single person, and eventually
Overly complicated.
Eventually it gets to him. I mean, you could probably draw it like to 100, like 15, 20, because everyone's like taking a small bit. Now that could all be defined if you really know the service, right? Like the PR is supposed to take 10, the label's supposed to get this, and then the artist gets the rest.
And that's autonomous. Those contracts can be executed autonomously without any human intervention. The technology that the performance rights organizations like ASCAP, CSAC, what their technology is 100 years old. and we're applying it to music streaming, and it does not work. So these are more